Good morning, friends. Yeah, this is Dr. Aravindan, Professor, Department of Tripoli, K.S. Rangasamy College of Technology, Tiruchengodu. Today, we are going to deal about the parallel operation of alternators. Uh, Synchronization and the parallel operation of alternators we are going to deal today. Still now, we are studied the constructions, operations, principal operation of alternators, and then EMF equations, then characteristics. Other things, other things we are studied. Today we are going to discuss about how the generators are made, parallel operation. Before that, we should know what is the parallel operations, what is the necessity of the parallel operation. That also we have to understood. We have to see that the single synchronous generator supplies the power to a load by acting as a voltage source whose frequency is decided by its prime mover speed. The current and the power factor can be determined by excitation provided to its field and then field and impedances of the alternator on load. Then the process of switching off an alternator to another alternator or it's a common bus bar without any interruption is called synchronization. Okay, this is the synchronization. And then the synchronous machine, which is to be synchronized, is normally called incoming machine. Okay, these are the in this background we are going to discuss about the necessary conditions for the parallel operations. Okay, the process in which switching of an alternator to another alternator or with a common bus bar without any interruption is called synchronization. Then conditions for parallel operations, we should to look into three important conditions before we are making the parallel operation. Okay, first one, the terminal voltage of the incoming machine must be same as the bus bar voltage, and then the frequency of the generator voltage of the incoming machine must be same as that of bus bar frequency. Okay, that should follow the generator formula. Already we know very well about that. The frequency is equal to number of poles and the speed, synchronous speed of the machine divided by 120. Okay, this would be the frequency of the, any machine. Okay, the third one, the phase sequence voltages of the incoming machine must be same as the bus bar voltage. The phase sequence is already this is R followed by Y and then followed by B. This should be called as phase sequences. That should be equal with the incoming generator and then bus bar voltages. Okay. Now, advantages of the parallel operation. What are the advantages? That also we have to know before we are going to deal about the conditions and then methodology of making the synchronization. That should be very essential. So, important conditions are, advantages are continuity of the supply is possible. Okay, when breakdown or shutdown of for maintenance of alternator in the generation stations, we should go for the parallel operations. Second important subjective of the parallel operations are repair and maintenance of individual machine can be carried out uh, 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 one after another, one after the another without affecting the normal routine work. Okay, depending upon the loading requirement, any number of alternator can be operated and remaining can be put off. Okay, it is economical and then improves the efficiency of the generating stations. The new alternator can be connected in parallel when the demand increases. This reduces the capital cost of the systems. Okay, these are the various objectives of the requirement for parallel operation of any alternator with the incoming infinite bus bar. So methods of synchronization of an alternator. This is important thing. How we are going to find out the above three method. That is the frequency of the incoming alternator, and then terminal voltage of the incoming alternator, and then phase sequences of the incoming alternator. These are the very important thing. The important parameter we have to ensure before we are going to make the parallel operations. Okay. So to ensure these three conditions, we should have three important methodology. One is a dark law method, another is bright law method, and a synchronous scope method. Let us see one by one. Okay, these are okay. Each and every method it should be satisfy the three important conditions, that is a voltage, frequency, and phase sequences. Okay, first methodology is called Darkla method. The Darkla method, the voltage for the two alternators is measured with the help of a voltmeter. The lamps are connected in such a way that the polarity of and the frequency for the two machines can be checked. And no resultant voltage will be appear across the switch terminals if the frequency of the two alternators is exactly same as well as their voltage are in exact phase opposites. So here lamp 1, lamp 2 and lamp 3, it is exactly connected with the same phases of the incoming generator and then under the existing generator or infinite bus bar. Okay, so that whenever the voltage is matched together, so potential difference across each lamp should be zero because of it should be in the phase sequence, same phasor and then opposite to each other. So if, for example, it should be 400 voltages of incoming generator and then the same 400 voltages it will be in the existing bus bar. If it is I'm presenting across the lamp, then it should be zero. Okay. It should be cancelled each other. So the bulb never glow. Okay. Then the voltage it should be uh, and then frequencies also. If the phase sequence is not matched each other together, so the lamp will be lamp potential difference across the lamp. It should be have a difference in voltages. So it should be like start to flickering. So that flickering long dark period, we are find out the long dark period. Using that long dark period, we should close the switch. In that particular moment, the exact synchronizations of the speed of the incoming alternator is adjusted in such a way that the light beats are produced at a very low speed and the alternator are synchronized during the middle of the dark period. So where the resultant voltage ER should be zero. The word middle is used as the lamp will not glow even though there is a sufficient voltage across it. So it becomes difficult to know the current instant of zero voltages. So in this methodology, we are not able to find out the exact position of the equal voltages and then phase sequences at the available dark period. Because of, as we already discussed, that even though it is a bulb in dark period, there may be a small voltage should be present between the incoming bus bar and the existing bus bar. To overcome this drawback, we should go for the next methodology, that is uh, bright lamp method. In the bright lamp method, it is since it is a very difficult to get the current instant of the zero in the previous methodology. So in this method, it is introduced that the lamp should be in opposite polarity. If, for example, L1 is connected between R phases and yellow phases, and lamp 2 it is connected between yellow phases and blue phases. Then lamp 3 it is connected between blue phases and the yellow phases. So likewise, incoming generator phase sequences and then existing interface sequences of the lamp which is connected should be in opposite in polarity. I mean, different phaser, different phasers. So that if the voltage it should be, same, even though because of the bulb is connected between various phase sequences, the bulb should be glow in very bright mode. So that in this particular bright mode conditions, we can able to connect the synchronizing switch for making the synchronization. And before that, we have to find out the voltage across using the voltmeter. We have to find out the exact volt available for incoming generator and then existing generator. Then if the frequency is increasing or decreasing, that also we can able to find out here. If the frequency is more in the incoming generator, the bulb it will be going to slowly it will be going to glow. That we have to adjust the stream input to the incoming generator to make exact the long bright period. So that in the long bright period we can able to find out that three conditions should be satisfied, that phase sequences and then frequency as well as the voltage across the terminals. These three conditions will be satisfied. Then we can able to find out the long bright period. In that particular moment, middle of the long bright period, we can close the switch. It should be our infinite bus bar, and then existing generator should be connected together. Then we can go for the next methodology, that is the synchronous scope method. In this method, as per the diagram is seen, it can be the lamp flickering is together is uniform. The synchronous scope consists of stator and rotor. The stator is connected to the incoming alternator. Then, the rotor is connected to the incoming alternator. The stator is connected to the existing alternator. So, it is consists of the rotating pointer, which indicates the exact moment of the closing and the synchronizing switch. If the pointer rotates clockwise direction, it indicates that incoming machine is running slow, whereas the clockwise rotations of the pointer indicates that the incoming machine is running fast. The rotation of the pointer is proportional to the difference in the two frequencies. The pointer should be rotated at a very low speed in the direction of the arrow marked fast as shown in the figure above, in the figure. So that we have to find out the exact center position of the rotor pointer. Then we can able to close the switch. In this particular moment, we can able to find out, we can able to confirm that the frequency, phase sequences, and then our voltages should be zero. Should be equal. Then we can able to find out the synchronization point, exact point. Then if we close TPAST switch, TPTP switch, then it could be making the proper synchronization of the machine. After synchronization, how the machine will be maintained the synchronization. That also very important point. Is synchronizing current and then synchronizing power and synchronizing torque. These three terminology we have to understood before we are going to make the generator or the incoming alternator should be make the load or should contribute the load. So here very important point is E1 and E2 will be connected parallelly. So we have a closed path. E1 and E2 we have closed path. In the closed path we have three terminologies. One is synchronizing current. E for the incoming generator is voltage. It is run voltage is it is lesser than the existing generator. Then exactly before that we have to understood E1 that is equal to E2. Then the local circuit voltage should be zero. That means ER should be zero. ER is equal to the difference of E1 and E2. Okay, if E2 will be lesser than the E1, then there should be a small voltage will be going to circulate, generated inside your local circuit. So that particular voltage is called ER. That ER will make the some current. That current is the synchronizing current. So the formula for synchronizing current is ISY is equal to ER divided by Z1 plus Z2. Then that any current it should be generated inside your local circuit. Definitely there will be a power. So power that power is called a synchronizing power. So synchronizing power TSY is equal to E1 into ISY cos pi 1. So synchronizing torque TSY is equal to PSY divided by 2 pi ns by 60. So now we can able to find out that E2 will be slowly, it is a small voltage will be reduced or it will be decreased than the E1. Then there should be a load angle alpha. Because of the load it should be reduced, voltage should be reduced then with alpha load angle. So once there will be a voltage difference in E1 and E2, then the result voltage ER should be there. That ER, it will be the vector addition of the E2 and the E1. Now it will be joined together. So with the ER, there should be a 90 degree with theta. Then ISY should be there. So that ISY and then ER, that should be in between that we have a power factor angle phi. So using this, we can able to find out the power and then power factor as well as our leading current. ER. Using that ER and then ISY and the E1, we can able to find out ISY, PSY, and the TSY. So that TSY will again is going to act as a E2 as a motor mode. Then it should be a synchronous motor. So this synchronous motor will always run as the synchronous speed. So now that lost in synchronization, it will be lost in voltage or lost synchronization. It should be put into again automatically to put into the force because of rated speed will be there. Then rated voltage will be generated. Then the voltage E1 and E2 will be matched together. So Now, how the second position second parameter which is going to deal with the parallel operations is the effect of change in excitation of alternator in parallel mode. So if it is a no load, E1 is equal to E2, that is a no local current. That means, as we had discussed earlier, there is no ISY. So excitation of the alternator 1 is increasing, E1 also increases. That means than E2. Okay, that is a very important point. Then resultant in this resultant, ER is equal to E1 difference E2. So there will be a circulating current ISY. Already we have discussed. Now ISY lags ER by 90 degree in this mode. Is demagnetic effect will be there. So it is reduces the EG voltages of the incoming generator. Then if ISI leads ER by 90 degree, it will be going to create the magnetic effect on the incoming generator. It increase the EG voltages. Okay. In this background, just we are going to discuss about. In the next class, we are going to discuss about the how our generator will going to share with the load conditions of with the load conditions, how the excitation power will be going to increase the power factor, or it will maybe decrease the power factor as per the load in nature and then excitation. Everything it should be deal with the next class. Thank you for your patient listening. Thank you for everyone for watching this video.